So this is the tale of Romeo and Juliet. So Romeo and Juliet are star-crossed lovers, and they both start out on opposite sides of this graph. So Romeo will always be running from the right. So Romeo is going to be over here. Romeo and Juliet will always be running from the left. Now, really, they don't run from that far to the left. Did I spell Juliet wrong? Probably. Yeah, she doesn't have an extra T. Okay, so we're going to talk about something called limits today. So the first one, I'm just going to start with something easy. I'm looking for the limit as x approaches -3. So I can look on my graph to where -3 is. And the idea is that Juliet is going to run towards x equals -3 along the graph. So she'll be running down this way, and Romeo will be running this way. So they're both running from either sides. And the question is, do they actually meet at the same point? So if I were Romeo, this actually works better if I have two hands happening at the same time, but I can't. So Romeo would be running from here, and at the exact same time, Juliet would be running from this side, and we can see that that they would have no problem meeting up at this point here, which is at a location, y-coordinate of -6. So for this first one, I would say the limit, Lim, as x goes to -3, that's what that says, limit as x goes to -3 of our function, which is f at x, is equal to -6. So that's the limit as we approach -3. Now that's a boring spot because the curve is continuous there. So now let's think about what would happen if we go towards a discontinuous spot. So for instance, x equals -1. If I go to -1 on my graph, I can see that my graph is actually split. It's discontinuous, so it doesn't just continue on between these 2 points. So once again, Romeo will be running from the right and Juliet will be running from the left. And imagine that these lines are moving at the same time. When Romeo runs from the left towards a -1, Romeo ends up here. And when Juliet runs, did I say the left? I shouldn't say left or right. Romeo's running from the, does that look like left to you? No, that is from the right. Anyway, Juliet is running from the left. And as she runs, she ends up here in this spot. So in this case, I could write something like, there's not enough room, the limit as x approaches -1 from the left, so a little minus sign means from the left, of f at x is, so from the left, that's Juliet, and she lands at -2. And totally going to run out of space here. And the limit as x goes to -1 from the right, so that's a plus sign for the right-hand side of the graph, for the positive side of f at x, and that's what Romeo did, is +4. So notice that they don't meet, and because they don't meet, we actually say the limit as x goes to -1, like the full limit of f at x, does not exist, DNE. And I need to write that down somewhere. Does not exist. The limit doesn't exist because they don't meet. If I look at the limit as x goes to 0, I don't need to separate the left and right side. Here's 0, and from the left side, Juliet will reach that point. From the right side, Romeo will meet at that point, and so the limit is 4 of f at x is the y-coordinate 4. So when it's continuous, it's a lot easier. X equals 4 is an interesting case. So notice that at x equals 4, the function is way down here. And so, in fact, f at 4 is equal to -3. Right? So it almost makes you think that the limit as x goes to 4 of f at x would be -3, but that's actually not true. So if I'm thinking about my star-crossed lovers, and Juliet is running from the left-hand side towards this hole. So we see a hole in the graph there. And the hole means that the function doesn't exist up there, that the value of the function is way down here. But when Juliet is running from the left-hand side towards that hole, and Romeo is running from the right-hand side towards that hole, notice that they will be able to reach each other here. They might fall through the hole, but either way, they reach each other in this spot. And so the limit from the left and the limit from the right actually ends up at this point here at +6. So although f at 4 is equal to -3, the limit as x goes to 4 of f at x of my function is in fact 6, because that is where the two star-crossed lovers meet. X equals 5 is a weird one. So notice that for x equals 5, that the graph is discontinuous and it's split. So half of the graph is here and half of the graph is going down here. Oh, it's not listening to me. Going down this way. And so what we would notice is that for Romeo would run off to +infinity as he approaches 5, but Juliet actually would run to -infinity. So in fact, the limit does not exist. So, the easiest way to do that is just to say the limit as x goes to 5 of f at x does not exist. And you could show the two ends, like the limit as x goes to 5 from the left of f at x goes to infinity, and the limit as x goes to 5 from the right-hand side of f at x goes to -infinity. These are not the same, and so the limit does not exist. Okay, one more. This is the limit as x goes to infinity. So when I'm thinking about x going to infinity, I'm thinking as I run to the right as far as I can possibly go, but on the graph. So notice this time I actually only have Juliet running because Romeo runs from the right towards the left. So the limit as we go to +infinity is, where does my graph go if I were to go to +infinity forever and ever, run to the right as far as I could? Notice that my graph really has an asymptote here. And so the limit is +7. Although it doesn't ever reach +7, the limit as x goes to infinity of f at x is 7, because that is where there's a horizontal asymptote. Notice, I didn't put it in the list, but if I said, where does it go, what's the limit as x goes to -infinity, that would be this graph, and it's clearly going to infinity. So we could actually say the limit as x goes to -infinity of f at x is equal to +infinity. So it's limits on a graph. That's the first part. I'm going to stop this, and then I'll do more limits in another video.